Okay. All right, let's go to Desmos. So let me go back. Let me just, so I got to share, so I'm going to share Desmos now. Okay. All right, so again, in that example, I wanted you to graph the normal so we're assuming we have a data set, that's normally distributed. And the mean is 10, standard deviation's 3. And we want to find first the percentage of data values between 9 and 10. Okay, so we have 10. Just clicked on the wrong thing. Here we go. Between 9 and 10, we have our normal distribution, which is 10, and the standard deviation is 3. Okay, good. So I just graphed it. Now I want to zoom in just a little bit. Let me make sure I got the numbers right. Yes, I did. Good. So again, I know it looks almost horizontal, mostly because the standard deviation is kind of high, but that's okay. Let's find the percentage of data values between 9 and 10. So we're going to type in a minimum, get rid of that, a minimum of 9 and a maximum of 10. You can see, I'm going to zoom in a bit. Okay, I'm also able to zoom in on my mouse. There's a little wheel between the buttons. I don't know if you have that kind of mouse or not. You can use that to zoom in. If not, just use the plus and minus. But you can see we have this area. And it turns out that area, okay, is about 0.130, what is it, 56 actually, if we round. So if we were to round to 3 decimal places, which is what I said to do, we would get about 0.13056. And then you convert that to a percent, and you get about 13.056%. So again, this is not a percent the area, but you can easily make it into one by just multiplying by 100. So if this was our data set, the percentage of data values between 9 and 10 would be about 13.056%. Now that was for 9 and 10. And the next one was, let me see, wrong thing. Click the wrong thing. There it is. There it is. The next one is between 11 and 13. Okay. Let's see what that is. So that's between 9 and 10. Well, for 11 and 13, it's the same process, right? We're going to have minimum of 11. Maximum is going to be 13. Now, let me just zoom out a bit so we can see it. I'm going to click and hold, and we get this number. So we have about 0.21079, right? In my notes, I have 0.210786. But again, if we round it, if we convert to a percent and round, we get 21.079%. So that's what we get. So that is what we get. Okay, let me just stop this and get back to the notes. Here we go. Again, I apologize for having to go between Desmos, the notes like this. I don't know how to share more than one thing through Blackboard. I'm not sure if there is a way, actually. Although there might be, I just don't know. But you do have the notes in front of you. So again, these are the solutions we get. I'm just using, again, Desmos. So what I'm going to show you next, you might be thinking is pointless, but it's really not actually. But I do need that textbook that I just closed. Let me just get to it again. Here. Where is it? No. There it is. Okay. So I just closed something I need to get, so I just reopened it. Let me get to that page. Here it is. Good, that's what I need. Okay. All right. So these are our solutions. So with Desmos, using z-scores and what I'm going to show you next, you might be thinking, well, what's the point of that? We have Desmos. It's good to know how to solve this using z-scores. You know, you may not always have Desmos, for instance. I mean, I know you could download the app on the phone, but, you know, what if you don't have your phone with you and you have to calculate this such a percentage as we just did? Well, you can still do it. Still good to know how to calculate this kind of area, percentage that is, using z-scores. Namely, what we're going to do is this. Essentially, what we can do is do what we did before, convert the score to a z-score. And remember, when you convert to a z-score, you're essentially working in the standard normal distribution curve. I mean, that's really what you're doing. Z-scores are essentially the, how do I say this, the data values for a standard normal distribution. But that's might be a little bit beyond the scope of the class, what I just said, but let's keep going. So basically what I'm saying is we can use z-scores to calculate these percentages and find the areas as well. There is a table provided in the book, but let me show you this before I get to the table, actually. What's going to happen is it's going to give you the area to the left of the z-score under the graph for different z-scores. That's what it's going to give you. So when it's going to give you different values. You'll see in the table shortly that what it's actually giving you is the area under the graph to the left of the z-score. Okay, let me get to the table now. Not there. Here. Okay, let me just stop this again. Oh my gosh. My goodness gracious. Here it is. Here it comes. This table, I mean. Okay. This is again in the textbook. What page it's on? It's on page 10. No, not 10, excuse me. It's in chapter 12, the 10th page in chapter 12. But this is the table I'm referring to. Basically, you have z-scores and you have these different areas, which is what we had before percentages, essentially. And this is all area to the left of the z-score. So this is the area to the left of the z-score, -3. This is the area to the left of the z-score, -2.9, and so on. And at 0, kind of like what I hinted at before, the area is 0.5, because again, the total area is 1. You can also see here how as the z-score gets bigger, the area is getting closer and closer to 1. We said the area under the graph is 1, so. But this is the table that we can use to help us. So I'm probably going to have to share back and forth like I've been doing with Desmos. I'm going to have to do that with the table though. So, okay. All right, that's okay though. Let's do that. Let me get to the notes again. Okay. All right. So let me get back to the notes. I should put I'm not sure if there's a way to put the table in the notes, but that's all right for now. But again, this is what I was trying to say. The table entries, what they're giving you is this area for different z-scores. The area to the left of the graph and under the graph and above the horizontal axis. I mean, it does mention it doesn't give this visualization in the book, at least not there. So that's why I presented it here. Well, wrong button. So I clicked the spell check button by mistake. Let me get back to my notes. Oh, gosh darn it. Here we go. All right. So here, let's do an example actually. If let's say we wanted the percentage of the scores from the previous, previous example, couldn't think of the word. well, not the previous example, excuse me. Let's say we have a normal distribution, and let's find the percentage of data values to the left of the z-score, 1.7. Or if you want, you can think of it this way. We did an example, we're finding the percentage of scores less than the data value that corresponds to this z-score. So you can imagine that what we already did was we converted the data value to this, 1.7. Okay? And we can get that using that table. I mean, if you looked in that table, let me get back to the table actually. Again, the notes I emailed, so you should have these in front of you. So if we want the percentage of scores to the left of this z-score, so let me say it again, you can imagine we're in an example. The data value we converted, we got its z-score to be 1.7. So let me, what am I doing? Here we go. So for a 1.7, which is what it was, okay, if you looked in the table, right, at 1.7, it looks like it's here. See if I can highlight it, okay? You can see that, hopefully you can see there, it's 0.9554. So the area under the standard normal distribution to the left of 1.7 is 0.9554. So the percentage of data values then would be about 95.54%. So the percentage of data values to the left of that z-score would be about 95.54%. I really hope that makes sense. But again, that's in the notes, which I sent out. What if we wanted instead to the left of the z-score negative 0.754? So it's in the notes, but what if we wanted instead to the left of the z-score negative, let's say negative 7.54. 0.754. So to the left of that z-score, which I just put in, that's a z-score. Well, notice that that z-score is not there in the table, is it? What we can, however, do is round to one decimal place. That's generally what you have to do to use this table. You have to round. So instead, we can round to negative 0.8. Okay, we can round to negative 0.8, and you could see, let me zoom in a bit so I don't have to keep going back and forth. You can see on the table that at negative 0.8, where is it? Right here, hopefully you can see it's in the second column, 8 rows down from the top. You can see it's about 0.2119. 0.2119 here. Again, we rounded because the z-score negative 0.754 is not in the table. However, we can round to negative 0.8 and we get this. So the percentage of data values to the left of that z-score is about 21.19%. So that's what happens here. Okay. Let me get back to the table. Again, the table, it's in the textbook, so. Okay. So that's what we have here. Right? So again, that's what we were doing.